finish it. You don't have to write it down. Just talk to the person next to you. So say, I noticed blank or I wonder blank. Okay? About the video. You have 30 seconds. Go. I noticed. I wonder. I noticed. I noticed. Yeah, the rocks are always changing. Yeah, that's true. Correct. Correct. Forever and ever. Because rocks are so cool, right? Waterfall, waterfall. Thumbs up, I liked the video. Thumbs down, I was really sad, but I liked it. Thumbs sideways, what are you doing, Lisa? Okay, alright. Today we're gonna have a chance to do something similar. It's not gonna be exactly the same. We won't have time to do a whole movie in this class, but before I get there, I want to remind you what this week is gonna look like. So tomorrow we're meeting at the garden. Just a reminder, tomorrow we're going to be at the garden as long as it doesn't pour on us. If it's not raining hard, just assume we'll be at the garden. If it's raining and you're not sure, just come to my door and I'll have a sign saying yes, we're at the garden or no, we're not at the garden. But assume we're probably going to be there. Wednesday there's going to be a medium test. Again, there's 2 booklets on Google Classroom that you can use to practice for it. Today's lesson is also designed as a practice for you. And then on Thursday, Friday, we're finishing up our Be a Scientist projects. I think after this week, there's 1 more week. So we'll work on those. Today, well, the first thing is I want you to remember that rocks are cool. And they all have a story, right? We'll get into that in a minute. I want you to understand how rocks materials get recycled over and over again. Remember that these rocks are not stationary. They're not just that rock forever and ever. And then I want you to create a model of the rock cycle. And I'll tell you how we'll do that in a second. So we know so far what we've talked about in Earth history. This whole unit, we've been looking at rocks, right? And we're looking at rocks because we know that they're good storytellers. They can actually give us a lot of information just by looking at them and figuring out what type of rock they are. You know a lot, okay? So what we're gonna do, because we're starting to wrap up the entire Earth history unit, I'm gonna have you guys talk with the person sitting next to you. Again, if there's no one sitting next to you, talk to the people next to you or behind you, okay? 3 questions. 1, where do rocks come from? 2, what types of rocks are there? There's 3 types. And then 3, do the rocks stay the same forever? Are they static or do they keep changing? And why? Okay? I'm gonna give you a minute and a half to talk about these things, okay? Sorry, 1 second. If you need some support with starting your discussion, I have some sentence frames here. I think blank because blank. I notice or I wonder. I disagree or agree with blank because blank. Okay? Alright, you have a minute and a half. Talk to your person sitting next to you. Go. What came first? Rock came first. they said or what their partner said about where do rocks come from. Nice vibration. From Earth, yeah. Anything more specific, Cedar?
Oh, from magma and sediments.
Okay, so sedimentary rocks come from sediments, right? And then you said something about magma. Where does that magma come from?
Inside the earth.
Inside the earth. Which layer of the earth?
Like
The one that's made up of molten rock.
the core.
Not the core. It comes from the mantle. Yeah, it comes from the mantle. Remember that mantle, that whole layer of mantle is molten rock, right? The very top part is kind of semi-solid, but the part underneath is pretty liquidy, right? And so what's the first rock that came? So there's three types of rocks. What are they? Sedimentary, igneous, and metamorphic. So which rock must have come first? Igneous. Because the first rock that came was just that molten rock that started to solidify, right? Okay. And did that rock stay the same forever? No. Why? Why don't rocks just stay whatever rock they are? Elia, for the next part, raise your hand. Okay. What's in the environment that's making them change, Bren? Yes, you're right.
They're eroding and weathering away, and then they're like turning to more things.
So one thing that's causing them to change could be the weather, right? The environment. What else can be causing them to change? Because the rocks aren't static. The earth isn't static. What is it that's moving in the earth? You want to give a shot? Tectonic plates. So remember, the earth keeps on shifting, and every time that those plates move, it keeps changing the rock. Right? So plate tectonics, the weather, all of that has to do with why rocks don't stay the same forever. Okay? So we talked about the rock cycle last week, right? So can a sedimentary rock change into an igneous rock? Thumbs up, yes. Thumbs down, no. Okay. You okay?
Yeah.
Okay. Can a sedimentary rock turn metamorphic? Thumbs up, yes. Thumbs down, no. Okay, yes it can. Can a metamorphic rock turn sedimentary?
Yeah.
Yes? No. Okay. Can a sedimentary rock turn igneous? Yeah. They can all turn into each other, right? So now question, is this rock cycle, is it linear? So does one have to lead to another? So for example, if I have an igneous rock, I need a metamorphic rock before I get a sedimentary rock? Is that linear? Or is it a cycle where either one of them can go from one to another? Who votes linear? Raise your hand. The rock cycle, is it linear or is it circular? A cycle, raise your hand. There's some people that are not sure. I want to try that again. Who says it's linear? So one has to come after another. Who says that it's a cycle? Raise your hand. We're going to do this until everyone shows me a hand.
Everyone just raise your hand right now.
It is a cycle. So remember that all of them can turn into each other, okay? You don't need one for the other. Ellie, is that a question?
Yeah.
Yeah.
How do you sedimentary rock into igneous without metamorphic rock?
It melts. You're right. It's missing the arrow, but it could just directly melt. Because remember, what igneous rocks are made of melting and cooling. So as long as it goes like in the mantle where it's really hot. Yeah. All right. So one last question, and then you guys are gonna get to do stuff. How long do these processes does it take? So in the movie, in the short little film, did anyone notice the time frames in that film? Cedar, what do you want to tell us about the time frames?
It kind of started like around when the dinosaurs were there.
And it ended where?
It ended in like modern.
More modern time, right? So did this take like a day, or did this take millions of years? Millions of years. For the most part, all of these changes happen over really, really long periods of time that it's hard for our brains to comprehend. However, there is one rock type that can form kind of instantly. Which one is it? Which igneous? Extrusive. Why the extrusive? Why does it form fast? It can form in seconds, it can form in days, it can form in hours. But compared to a million years, that's really short, right? Cool.
What a volcano erupts if lava's too hot for like the outside to just frozen solid.
Yeah. So when a volcano explodes, that rock turns solid really fast, right? So keep that in mind as we're gonna do today's activity. So what we're gonna do is I have created a choice board for you. Has anyone ever heard of a choice board? So it's when you have an assignment, so I'm giving you an assignment, you guys tell me about the rock cycle. But I'm giving you a choice in how you tell me about the rock cycle. Okay? What that means is, so I'm giving you 3 options. You have to choose just one of those 3 options. It is gonna be for an SVP grade, so make sure that you turn it in through Google Classroom. I'll talk about that a little later. Your job is to tell me what you know about the rock cycle. So, do you want to just tell me there's 3 types of rocks? No, you want to be a little more detailed, right? You want to give me all of the details that you need. So, we're going to have 3 choices. The first one, if you feel like your strength lies in writing, you're going to write me a short story. It's fictional, right? You're going to tell me a story about a rock and what's happening to that rock. If you feel like your strength lies in drawing, you're going to draw me a comic strip. About 20 panels, the comic strip. The fictional story can be about a page. I'll show you guys an example in a second. Or if you feel like your strength lies in organizing things, you can also do that. I'll show you what I mean in a second. So just for clarifying the way you submit this, if you're doing a fictional story, you can write it or you can type it. If you're doing a comic strip, it's going to have to be on paper because you're drawing. And then if you're organizing it, it's going to be on the computer. And let me show you what this looks like. So on Google Classroom, you're going to have this slide right here. You're going to click on whichever one you want to work on. So say that I want to click on the story. If I'm going to write a story, there's a lot of words. Don't get spooked by the amount of words. I know. The instructions is just this part. The rest of it is all examples to help you. Okay? So don't get spooked. So I want you to include what happens to the rock as it's moving from one type of rock to another. You gotta give me lots of details, okay? And then I included the vocabulary I want you to include, so sedimentary, metamorphic, igneous, weathering, erosion, all of that kind of stuff. That's the questions at the end, okay? And then it's gotta be about a page type. So the instructions for the comic are very similar, except for, of course, instead of writing, you are going to draw. Okay, there has to be some words to it, but it's mostly drawing, about 20 scenes. So the last option is something called the Freyer model. Has anyone ever seen something that looks like this? Has anyone ever used it? Yeah, a couple people. So the way that you read this is you have a topic in the middle. So I made an example on fossils. So your topic is, let's say, fossils. On one box up here, you're going to talk about how they're formed. On the next box, you're going to do the characteristics of it. pass, right? And then you create a fossil. Some characteristics are only found in sedimentary rocks. They're very rare, right? And then there's examples and non-examples. If you choose this option, you are doing this model, this organization model, for all three types of rocks. So you're gonna have sedimentary rocks, you're gonna have igneous rocks, you're gonna have metamorphic rocks, right? You're gonna do the 4 boxes for each. And then you're gonna tell me how they relate to each other. What processes change one to the other, and you have to give me examples of each type of rock. Capiche? Now, if you're gonna ask me which one's easier, I'm not gonna answer that question because it really depends on you. It depends on which way you learn best, and it depends on which way you can show me what you know the best. So, it is very little times that we as teachers give you guys choice in what you want to do. We're exercising that right now, okay? So you get to choose which one. Figure out the one that works best for you. Now, I do have an example that you can look at. Now, I was doing this example kind of late at night, so I didn't completely do it by myself. AI helped me. Now, warning, you may not use AI for this. I want to know what you know, okay? And AI isn't perfect. There's a lot of mistakes in this. The actual writing is mostly okay. Once you get to the comment, there's so many spelling errors in there, okay? But I left it there so that you guys can take a look at what kind of ideas I'm looking for, okay? There is a comment down here, and then here's an example of the writing. So it's not super long. This one's slightly less than a page, but the margins are really big. So, any questions? All right. So this is how it's gonna work. When I call your table, you're gonna grab your computer if you feel like you need a computer to work on this. If you're gonna do the comic option, I have some just white sheet of paper. I'm gonna put it on this table here, white paper, rulers if you want to draw your boxes for the comic. If you are gonna do the comic, please make sure you write your name on it because I'll collect it because we probably won't finish today. And then if you're gonna do the rest of it on the computer, then grab a computer. Okay? When I call your table, you're either grabbing a computer, or you're grabbing a paper, or you're grabbing a pen. Got it? Make sure you use your notebook. Everything is in your notebook. You can use that as a resource, okay? Let's see, table 3, table 4. Grab your computer. If you feel like you need But you have to make a copy of it. Can't write on the original. So file. Remember, make a copy of the Freyer model. You can't write on the original. No, go back to the original. Go to file. Make a copy. Axel, sit over here. Make sure you make a copy if that's what you're doing. You are doing this on your own. I want to know what you know. Yeah, Oscar. He said if he can work next time. I said yeah, he can work next week. It's on Google Classroom. So click on that. Which one you want to do? That one? Organize it? So you click on and then make sure you make a copy, okay? So click on you make a bullet point by just typing and then pressing enter and it'll make a new bullet point. I know, crazy. I don't know. You tell me. I don't know. You want to, okay? I don't know. Yeah, that's a great way to do it. I know. Yeah, don't worry. How does easiest to sediment? So we're making sediment. How do we get? How do you go from igneous to heat and which is called pressure. Yeah. How do you go from igneous to how do you go from sedimentary to sedimentary? How do you go from igneous to metamorphic? Pressure and heat. Eve, how do you go from metamorphic to igneous? How do you go from igneous to sedimentary? Yes, weathering and erosion. How do you go from sedimentary to metamorphic? sedimentary to metamorphic. Which way you go? Heat and pressure. Cedar, how do you go from metamorphic to sedimentary?
It gets weathered and broken down into sediments and then gets deposited, then compacted, then cemented.
How do you go from metamorphic to igneous? Melted. Jenzy, how do you go from igneous to metamorphic? Igneous to metamorphic. What do you need? Not lock and you pull it yourself. How do you go from igneous to metamorphic? How do you go from metamorphic to sedimentary?
The metamorphic will breaks down and then gets glued back together by cement.
How do you go from igneous to metamorphic? How do you go from sedimentary to igneous?
That's the notebooks.